So at the deli counter, I order 1 pound of sliced provolone cheese. I almost never get exactly 1 pound. One time it landed on 1.00, and do you know what they did? They added more. And I was like, what are you doing? You got it exactly right. But he said it's because like the paper weighs something, so you didn't actually get a pound of provolone. I was like, he messed it up. It was perfect. But anyway, I order 1 pound of sliced provolone cheese. I almost never get exactly 1 pound, and I never get less than 1 pound. I learned that the deli workers have been told to always give between the amount requested and 0.15 pounds more. So I can represent this as saying 1 is less than or equal to X, and X is less than or equal to 1.15. This just means it's between these two numbers and including these numbers. This interval notation is the same exact thing. It means that X is between 1 and 1.15. And what do the square brackets mean? Anybody have a guess? Yes.
That could also be 1 or 1.5.
Right. So they can include those numbers. Notice down here, we don't ever include infinity because you can't get to infinity. And then this one, for example, doesn't include 2. So this means including the endpoint. And then we also represented this on a graph. So you see that graph there. And you did notice some things that were different between the different graphs. This one is X is less than or equal to 2. And this one has two choices. X could be less than or equal to 0 or greater than 2. And then you'll notice the interval notation and the graph. So I'm going to go to each group and ask something that you notice or wonder. So you can start with I notice or I wonder. And when I ask the group, just anybody from that group can answer, okay? Let's start with this group by the door. One thing that you notice or wonder.
One thing I noticed,
They are using open and closed circles on the graph. So those must mean different things. Excellent. All right, by the flag.
I noticed that they use the dots for the numbers and the arrows for the
They use the points for the numbers and then the arrows to go to infinity. Excellent. Points at numbers and arrows to infinity. Well done. All right, in the back next to Mr. Smith. Anything you notice or wonder?
What dictates related to whether infinity goes in the interval notation?
Like if it goes first or second?
Yeah.
Excellent. Okay. What dictates whether the infinity is first or second? And we will answer that. That's a good question. Either of you.
What is the in the thing that there's a parenthesis inside and there's a
Okay. So why is there a parentheses on one side and a bracket on the other? Okay. Excellent. Yes.
I noticed that the open circles move greater than or less than, and the closed circles move greater than or equal to and less than.
Okay. So open circle is used for this symbol or this symbol, the less than symbol or the greater than symbol. You guys need to tell me when you can't see what I'm writing. And then closed circle, the colored in circle, is this one or this one? Good. All right, what do you guys have?
This one is if they're using a greater than or equal to and associates.
Okay, so you notice that these two symbols? Okay. Since I have these here, I'm gonna not write further on that one. Thank you. All right, up front, what do you guys have? Anything you- Uh-huh.
Why are they in big symbols?
Why are we using infinity symbols? Okay. You guys have.
Why do you guys even view the implementation?
Excellent. All right, this group back here in the middle. Carolina's group, can somebody share something? Did you have a notice or a wonder to add? Beautiful. All right, so not only do the circles on the graphs compare with the less than or the less than or equal to, but also parentheses and brackets are also related to that. Good. So the parentheses give you the less than and the greater than. And then the brackets can give you the less than or equal or the greater than or equal. Good. All right, last group up over here. What do you guys have for me?
I noticed that the notations that don't have a starting and ending value, like overcrowding before and after
Mhm.
the X, they go on forever. So
Very good. Okay, so if it doesn't have a start point and an end point, then it goes forever. I'm going to say that out loud, but I don't have space to write it. These are all really good notices and wonders. Okay, let's go to the wonders real quick. What dictates if the infinity is first or second? Does anybody have an answer for that one? How do you know if the infinity is first or second? Well, notice what kind of infinity is on the left.
Negative infinity.
Negative. And what kind is on the right? Positive. So if it's a negative infinity, it will go first. And if it's a positive infinity, it will go second. All right, we always write our intervals from smallest to largest. So the smallest you could possibly write is negative infinity, and the largest you could possibly write is positive infinity. So this will always be on the left, and this will always be on the right. Why do we have a parentheses on one side and a square bracket on the other? I think we kind of answered that. The parentheses is for something it can't equal, and the square bracket is for something it can equal. Why infinity? If I say x is less than 2, it can be any number less than 2, like negative 100, negative 1,000,000, negative 10 billion, all the way to negative infinity. So when x can go on forever, we're going to have a negative infinity or a positive infinity. And then why u? U actually means and. I wonder, should that be the upside down u?
And
We-
it's the,
This is the and.
I would.
But this should be an or, right? All right, we're going to get back to that. This, I think it's the union of the two sets. So I think it is the or because it's the union of this set and this set. But in this case, we're using it for or. So it could be this one or it could be this one.
Yeah, that makes sense.
Yeah, I think it can be used differently too. Okay, down here, some of you guys already started this, but if you didn't, we're going to do it right now. At a cross-country meet, the fastest time was 17 minutes and the slowest time was 30 minutes. Represent the set of all times. So, in inequality notation, actually, let's start with the graph. Let's start over here on the graph. We need to show the set of times between 17 and 30. And so I'm just simply going to write a 17 and a 30 without trying to show the 13 marks in between. That's just a lot to write, right? All right. So it was set between 17 and 30 and all the times in between. Did anybody have exactly 17? Somebody did, right? Because it was the fastest time. So exactly 17 gets a closed dot because it can equal 17. What about 30? Should it be a closed dot or an open dot on 30? Also a closed dot because somebody got 30. And then to show all the times in between, we're just going to connect them. All right, so looking at that graph, does that look like our first example, our second example, or our third example? We've got 2 points and connected in between. Is that the first, the second, or the third? The first one, right? So we can use that as a guideline. The x is going to be between two numbers. And because I have two filled in dots, they're both going to be the less than or equal sign. What number is going to go on the left? 17. Good. What number is going to go on the right? 30. And then you can also use that first row as a guideline for your interval notation. Okay, because we're including the endpoints, you can use the square brackets and its smallest number, comma, largest number. When did our class start? All right, looking at number 6, it says x is less than or equal to -2, or x is greater than 1. Less than or equal to -2 or greater than 1. So looking on the first page again, does that remind you of the first example, the second example, or the third? All right, somebody suggest the third. Anybody agree? Good. All right, so it's going to look like this one. So we're going to have 2 intervals with a u in between. All right, if it's less than or equal to -2, the smallest number it can be is negative what? -2 is the biggest number it can be. So that's going to go here. The smallest number, -infinity. That was tricky, right? Because it's -2, but it could be smaller than -2. So it goes all the way back to -infinity. Now, question. On -infinity is always going to get a parentheses because you can head towards infinity, but you can never get there. But the -2, it might have a parentheses or it might have a square bracket. So what about this symbol here tells me if it's parentheses or square bracket?
It's a square.
Let's give her a chance. Say it. If it has an equal to? Yeah. So because we have an equal sign right here, this one right here, we also know that we have a square bracket. Okay? So that equal sign is what created our square bracket. And then a U for the second part. Now notice this one doesn't have a equal signs. U just means or. Okay, you could write the word or in between if you prefer. Okay, x is greater than 1, so it can start at 1, right after 1, not including 1. We use a parentheses for that. And greater than 1 can go all the way to what biggest number? Infinity. Okay, then if you take a peek at the front again, remember we're looking at the third example, you're going to have arrows going in 2 directions. So the first one is x is less than or equal to -2. So here's my 0. I have to go back 2 places to get to -2. Because it has an equals on it, will it be a solid dot or an open dot? I heard some votes for solid. You guys are good with that? Solid dot here at -2 and then less than or equal to. All right, then I have to find 1. Here's 0, so here's 1. And it says greater than 1, so I'm going to put here, and then greater than 1 is this way. All right, those are my 3 representations in set notation, interval notation, and graph. All right, the first one is x is less than or equal to 3. Because it has the equal sign there, that also tells us that we're going to have a square bracket right here. And it also tells us that we're going to have 1, 2, 3. We're going to have a closed circle at 3. So all those things go together. Equal sign, square bracket, closed circle. If x is less than 3, will the arrow go to the left or to the right? Left. The numbers less than 3 are on the left. Next one is x is greater than -2. So this one does not have an equal sign, and this is why we have a parentheses here. at -2, I'm going to have an open circle. So those three things go together. Greater, parentheses, open circle. All right, greater than -2, the numbers bigger than -2 are on the right. Questions on 1 and 2? Okay. Then it gets a little harder because we have to fill in more than one thing. I think it's easier to go from the set notation to the graph and then come back to this. So I'm going to do that. This says x is less than 1. So I'm going to 1. I'm making an open circle because it doesn't have an equal sign. And less than 1 is this way. All right, so now when I'm doing my interval notation, you always write the smallest number first. But if this arrow is going all the way to the left, what number is all the way to the left? Good. What kind of infinity? Negative infinity. So on the number line, all the way on the left is negative infinity. See, I just added it to the number line there. So that means I'm starting at negative infinity and I'm ending at 1. And because I don't have an equal sign, it's going to be a parentheses. And infinity always gets parentheses. Always. Questions? All right, again, I'm going to start with this one, go to the graph, and then I'll fill in the set notation. So this says from -3 to infinity, and because it's a square bracket, I'm going to use a solid dot. So 1, 2, 3, -3, solid dot, and then positive infinity is on this side. So it's going to the right. All right, so looking at that graph, is x greater than -3 or less than -3? You see the graph we just drew? It's this one. Is x greater than -3 or less? It's greater, thank you. So x is greater than -3. On the board here, I made the symbols for greater and less. Notice that the less kind of looks like an L. That's how I remember it. So when I'm looking at it, the less looks like an L.
Yeah.
Yes.
Wouldn't it be greater or equal to if it's just a minus?
Let's see, where am I? You're right. Okay. So you guys should also be correcting me when I make a mistake. Don't let Mr. Smith do it all. Okay. So here, because it has the square bracket, it should be or equal to. Good? Okay. All right, next one. We have both of the notations, but we need this. This one is less than 0 or greater than or equal to 2. So two different choices. Less than 0 or greater than or equal to 2. Check and make sure you got that one right. Okay, we did 6 together already. We're going to 7. 7, I'm going to start with a graph from negative infinity to -3. So 1, 2, 3. And close dot because of the square bracket. Another square bracket, so another closed dot, and then go to infinity. So when you write this as two inequalities, you should have x is less than or equal to -3, or x is greater than or equal to 0. Questions? All right, we're almost there. This is one way of saying x is between -2 and 3, including -2, not including 3. This is another way of saying the same thing. So I need to find -2 and 3. Which one gets a solid dot, the -2 or the 3? -2, good. Because of the square bracket. And then the 3 gets the open dot. All right. Here's a -3 and a 1. So notice this is looking just like this, so we can use this as our guideline, except of course this one has the open dot on the left. So X is going to be between these numbers, so I'm going to put a -3 here and a 1 here. They always point to the left. When we write them, they always point to the left. So only thing I need to figure out is which one gets an equal sign. Does the -3 get the equal sign or the 1? The 1, because it's filled in, good. And that means that the 1 will also get the square bracket. Okay. Raise your hand if you had a chance to try the word problem yet. Anybody get a chance to try it? Okay, only a few of you did. I'm just gonna pause for another minute. If you got a chance to try it, see if anyone in your group needs help. And then if you didn't get a chance to try it, you're trying it, you can see if anybody in your group can help you as well. Okay, so let's do the graph first. So the smallest temperature you could have is -2. What's the biggest temperature you could have? 100, yeah. But there are 2 other important temperatures here as well. What are they? 65 and 75. Now, we're not going to be exact, but we're also not going to be random. Like 65 is not going to be right next to -2. 65 should be closer to 100 and 75 should be even closer to 100. So I'm going to put 65 and 75. All right, so if I am happy when the temperature is between 65 and 75, including 65 and 75, I'm unhappy at the other temperatures, right? So I'm unhappy at -2. I'm unhappy at all of these temperatures until we get to 65. So I have this line here. Am I including -2? Am I unhappy at -2? Yeah, I'm including that one. Am I unhappy at 65 degrees? No, I'm happy at 65 degrees. So I don't include this one because 65 was included in my happy temperatures. So it's not in my unhappy temperatures. Same with 75. 75 is a happy temperature. So I don't include it in my unhappy temperatures. And then it goes all the way up to what? 100. And I'm including 100. I'm still unhappy at 100. So according to this graph, I'm unhappy most of the time. All right, so now that we have the graph to describe it, we can probably do our other notations pretty easily, right? Remember that the solid dot is a square bracket from -2 to 65. The open dot is a parentheses. The next open dot is also a parentheses. And then the solid dot, oh, I did it in the wrong place, didn't I? I'm just changing the title, interval. And then this is 100. Sorry about that. I got so excited about my square brackets though. All right, so then to do the inequality notation, there are 2 pieces to it. We haven't seen one like this before. One of the pieces is -2 less than or equal to x less than 65. So that's between -2 and 65, only including -2. Or 75 less than x less than or equal to 100. Definitely a tricky one. But you know what? Real life can be more complicated than some basic math problems.